Welcome back, grade 6 to Nelson Math, chapter 9, section 1. Today we are estimating products, particularly estimating products that have decimals. So let's take a look at our first one here. 5.7 times 12.77 or $12.77. You have numerous options that when you think about them, if they make sense, you are able to use. Let's see now how we can make this make sense. I am choosing to round my numbers to certain ways, and hopefully I can explain those to you in a way that makes sense. When you learned rounding at a previous grade level, you were told the 5 and above, give it a shove, 4 and below, put it down low. And that is correct. So we could round these numbers to 6. That would be rounded to the nearest whole. And we could round this number to 13. And we could round it to the nearest whole. So let's do that now. If I round both numbers according to our rules of rounding. So this comes to 6 times 13. So 6 times 13, we can do this a few different ways as we learned in our review. We could add 13 6 times. We could decompose this. 6 times 10 is 60. And 3 times 6 is 18. So 60 plus 18 is 78. So we could estimate this in one way as 78. However, this number would certainly be larger than our calculated answer. So it is larger because the 5.7 is smaller than the 6 and the $12.77 is smaller than the 13. We rounded up for both answers, which means that we are going to be not so close. We've definitely gone over, but we have different strategies for estimating. We could round the numbers, yes, but what if we rounded the numbers to a way that we probably would get a closer number? And this is where the practice and critical thinking comes in. 5.7, that's pretty close to 6. So I'm going to round my 5.7 to 6 like I did here. But 12.77 or $12.77, while yes, that's close to 13, I'm going to round that one down because I rounded my first one up. So let's round this to 12. So 6 times 12, once again, we can use any which method we want. Or I could look, well, if I have 13 sixes here, but this is just 12 sixes, I have one less 6. So this would be one less 6 than 78. So that would be 72. We could also do 6 times 10 is 60 plus 12, that's 72. So now I've gotten a somewhat closer product, which is probably going to be a little bit closer. We'll calculate it exactly at the end. But let's see if we do it a different way. What about if I left my 5.7 and I rounded that down to 5, like that? So if I round my 5.7 down to 5, I'm going to round my 12.77 up to 13. Let's see if this gets us any closer. So 5 times 13, once again, we can do this many different ways. I am going to do this by saying 5, if here we have 6 13s, here we have 5 13s, then 78 minus a 13 would be 65. And here we're a little bit closer. But this one, because we rounded the 5.7 down quite a bit, you can see that took our 65 quite a bit lower. So these are all good estimates. They're good, but we're not aiming for good. We're aiming for really good estimates. So let's see if we can get a really good estimate. And let's also see if we can use the information we already have. I could look at this 5.7 two ways. I could look at this as 5 wholes or 5 ones, 5 wholes or 5 ones. And I could look at the 0.7 as being very, very, very close to 3/4, because 3/4, as we know, is 0.75. Think of money, 75 cents. So we could think that. So if we thought 5 ones and 3/4, I could say, well, what is 5 ones and 3/4 times 12? Like this. So I could say 5 ones times 12 is 60, But what is 3/4 of 12? 3/4 of 12, let's see if we can find 1/4 of 12. If I have 12s and I cut it up into 4 pieces, I have 3 in each piece. So 3 plus 3 plus 3 plus 3. So 3 of those quarters would be 3 plus 3 plus 3, and that would be 9. So I could say 60 plus 9 is $69. So this is a very, very close estimate. I could also do it another way, and this one's a little bit more complicated as well, but I could round this to 6, and I could round, so 6 ones. I'll just make that clear on here. And I could round this over here to 12 and 3/4. So I just rewrote all of my numbers from 5.7 to 6, and then 12.77 to 12 and 3/4, which I wrote over here. So now this is like saying 6 times 12 and 3/4. I just wrote it out like this. I added an extra step so it could be clear. So what is 12 times 6? 12 times 6? Well, we learned up here it's 72. So I've learned that it's 72. But I have to add now my 3/4 of 6. My 3/4 of 6, if we look at this for just an instant, 0.77 is really, really close to 3/4. So I've rounded, even though it's still not a whole number, I've rounded my 12.77 to 12.34. I'm making it a number that makes more sense to me. Now, what is 3/4 of 6? 3/4 of 6 is 4.5. So I could, and the way we get that, half of 6 is 3. Half of 3 is 1.5. So 1/4 is 1.5. So 1.5 plus 1.5 plus 1.5 is 4.5. I can add these together. So 72 plus 4 is 76.5 when I add the 0.5 in there. These are all valid estimates. However, you have to be able to choose which one is the closest estimate. At the very end, of course, you are able to go ahead, take your calculator out and see which one. But please do all of this mental math, because this helps you to see what works and what does not work. We're trying to get you to do gymnasium mental math and be elastic in what we're doing. So the real answer, or the calculated answer here for 5.7 times 12.77, it's actually 72.79, or $72.79. So you can see that our estimates here did very well. And our closest estimate, not necessarily the best method, but it worked for us, was this 6 times 12. So we rounded the 5.7 up, we rounded the 12.77 down, and we got really, really, really close with this. So I would encourage you, please, to use these different types of estimations, and then you're going to be able to get very, very close. Look how close we got. We got 79 cents off. So we got very, very close, even though all we did is what amounted to grade 2 multiplication. That's all that we did. So I'm encouraging you, please, grade 6, to do this type of mental math, this brain elasticity, to help you move along in your critical thinking and brain growth. Thanks, grade 6. Have a great day.